Hello there, this is Michael Gio, and today I want to talk to you about basic fermentation. This is going to be a series of videos that I want to prepare that are related to fermentation. What is fermentation and why is it important? Those are the things that I want to cover during this video. But before I go into the details of what I want to cover or my objective for this video will include a basic recipe of making bread. So if you're not interested in the scientific part of the fermentation, in this case using a yeast in order to make bread, you can go to this time in the video and then you can skip there and just watch the recipe to make this beautiful and delicious bread. But if you're interested in the basic part of the science of it, stay here. So what is the definition of fermentation? So in fermentation, you take a molecule, typically a sugar, and turn it into different other molecules, which the goal is to take energy out of it. Now that's a very, very vague definition of fermentation, because in this case, that is metabolisms. You take a molecule and then you turn it into end product. A big molecule into smaller molecules, that is metabolism, actually is catabolism. Also in metabolism, you have anabolism. Anabolism is you take those smaller and build up something. So we have defined metabolism, but still fermentation, what is it? So you take that sugar, use that sugar, break down that sugar, produce energy, and in this case it would be a very quick energy, fast energy, and turn it into this end products. Most of those end products during fermentation are toxic for the actual organism, and we humans take advantage of that because most of those products are not toxic for us. But the main difference between metabolism and when we try to define fermentation is the absence of oxygen. Yes, if we remove the oxygen from this media or from the environment that these organisms, yeast or bacteria, are growing, then they go into what is called survival mode. And because they are in survival mode, now they produce energy without that oxygen. Now, if you look in perspective, yeast or bacteria would go through regular metabolism versus fermentation, the bacteria or the yeast would go and perform regular metabolism. Why? Because when they're doing the regular metabolism, they would get more energy than when they're actually fermenting. Now, we have discovered that if these organisms are in some sort of environment that lack of oxygen, they start fermentation. And typically are secondary metabolites that produce CO2 and heat. Now, that CO2 and the end products, those are the things that we humans use for different things. For example, in this case, to make up the bread, ethanol is produced and gas is produced. We use those ethanol and gas in order to make the bread. How? Let's talk about the fermentation part. There are three main ingredients. First of all, the yeast. That's one of the most important. Then sugar. Without the sugar, even though we have the yeast, then we cannot perform the fermentation. And in terms of this recipe of the bread, then we need flour. And in this case, the gluten that is in the flour. If we're talking about fermentation, you need an organism. Microorganisms could be bacteria or a fungus. In this case, a yeast is a fungus. Then the bacteria or the fungus would eat the sugar and produce secondary metabolites. That is a fermentation. And this has to happen when there is not that much oxygen. That is how and why this bacteria or yeast or fungus would perform the fermentation. But in this case, for the bread, we need one main ingredient, which is the gluten that is on the wheat-based flour. Can we make bread with, let's say, yucca roots? Yes, or cassava? Well, we can, but it's not gonna grow like the flour bread. Why? This is what I'm gonna explain to you.
Gluten is a combination of two main proteins, prolamine and glutamine. These proteins get attached and then form some sort of like gum, some sort of gooey thing. They get attached to it. And that is why you have to sort of knead the flour. When you're doing that and adding water to the flour, then you are creating this component that is very like gum, very chewy and gummy. That's what you want. That's why we need the gluten. Why we need that? Well, you get the sugar in that same dough, you put the yeast in that same dough, you combine that. What is going to happen is the yeast would detect that there's not that much oxygen. Because there's no much oxygen, then the yeast is going to say, well, I either die or try to do something to metabolize, to produce energy, right, to survive. And in this case, the yeast decided to take that sugar and perform the actual fermentation. And what it is it take that sugar, turn it into different things, but the two main ingredients are, in this case, ethanol. Yes, ethanol, the same ethanol that is in the beer, wine, etc. And CO2. CO2 is a gas. Okay, so when this is happening, it's producing a little bit of heat, but the main thing is the CO2 and that ethanol. It's not going to produce that much ethanol of, like, let's say a beer or wine, because this fermentation wouldn't happen in just a few hours. In my recipe, it's going to be 45 to 60 minutes. But if fermentations that are like beer, wine, it take up to a week or 2 weeks. So you sort of get the picture here of the amount of ethanol that is produced. But the important thing is that CO2 that is producing. So imagine if you have a gum, right? And then when you make a bubble, you have to blow air to it and you create a bubble. That is the same principle that we have here. We have that gummy thing, we have that dough that is compacted, and those two proteins from the glucans are like all together attached to them. So when this yeast is getting the sugar and turning it into ethanol and gas, then it's gonna start like growing. Just the same thing as the chewing gum example. So it will start growing just as you can see there, and then we get our bread.
In the past, we didn't necessarily use the actual yeast. Now you buy dehydrated. We use a mother dough. And what it is was there were yeast growing in that mother dough. So you take a piece of that, put it with more dough, mix it, knead it, right? You have to knead it a lot. And then now all the yeast are spread in the dough. So that yeast that is in there can actually use the sugar in order to perform this process of the fermentation. Now, I haven't talked to you about the actual yeast and what it does inside the bread. I told you that it would ferment, create this bucket with the gluten, but what exactly is happening in there? So that tiny yeast is using that sugar in order to produce the ethanol and the CO2, right? But what exactly, why this yeast decided to do this?
Now, if you feel a little bit more nerdy today, let's go to the blackboard and then I can explain you what exactly is happening in there.
All right, as I promised, let's get a little bit nerdy. So the actual thing that is happening inside that bread is start with glucose. Glucose is a sugar of 3 carbons. Not 3 carbons, definitely 6 carbons. So I'm gonna draw a molecule of 6 carbons, referred here as spheres, right? So there is this thing that is going on in our cells that is called glycolysis. And glycolysis is when our cells get that glucose and produce something that got us ATPs or energy. So in other words, we get the glucose during glycolysis and another type of process, and then we get energy in the way of ATP. And we get up to 30 something, 40 ATPs. Let's say here 38, which is the more basic number, right? 38 ATP, so per that molecule of glucose. So what happened is When we start metabolizing the glucose, we produce something that is called pyruvate. Pyruvate, which is a molecule of 3 carbons. 1, 2, 3. So in other words, is from these 6 carbon molecules, we get these 3 carbon molecules. And we actually get 2 of those. So every time that we get this molecule of glucose, we would get 2 of these 3 molecules of glucose, and this is called pyruvate. From here is very interesting. In the presence of oxygen, we do something that is called the Krebs cycle. And after the Krebs cycle, we go to something that is called the electron transport chain. In there, and with all this process, we got energy. We got those ATPs that I was talking about. Okay? So in the presence of oxygen, we get a lot of ATP, a lot of energy. But if there is no oxygen, okay, no oxygen, we do fermentation. And this is pretty much what we talked about. We need sugar, no oxygen or very low oxygen, then these organisms perform fermentation. And the fermentation, as I said before, is pretty much taking that glucose and turning it into energy. There's a big problem with this, is like fermentation does not give you a lot of energy. It could give you up to 2 ATP. So in other words, which one is better? Perform glycolysis with oxygen to give us a lot of energy, or perform fermentation that give us only 2 ATPs or low energy? Well, I would definitely take this pathway, obviously. The problem is, if I don't have oxygen, if I decided to do this pathway, I'm going to be dead, right? They cannot survive because there's no oxygen. So in this case, this is survivor mode. So when these organisms decide to ferment, it's pretty much saying, okay, I don't have oxygen, I need to survive. And in order for me to survive is by doing this, the fermentation. I don't care if from each molecule of glucose I get only a little bit of energy, I don't care, but I'm surviving. So in other words, yes, it is a waste of glucose, all right? You're wasting glucose. But the thing is, survival mode, I need to do whatever it takes in order for me to survive and produce those 2 molecules of energy. Now, check this out. So remember we start with the pyruvate. Now this is no oxygen, all right? And this is gonna be called fermentation. All right, we are now doing the fermentation. So, and of course, we're talking about, in this case, the yeast that we're going to use in order to create this awesome bread, right? So now we have, from that glucose, we have that pyruvate. That pyruvate gets turned into acetaldehyde. And then from acetaldehyde, we produce ethanol. In the process of turning this pyruvate into acetaldehyde and then ethanol, we produce CO2. This is the gas that I need in order to make this bread grow. Okay, so that's the gas. At the end, we produce ethanol. So at the end, we produce ethanol, but as I mentioned before, it's not going to be enough ethanol in that bread in order for you to get drunk or to feel, oh yeah, this is a drunk bread. No, right? It's going to be enough, all right, to pretty much make that bread to grow, because this is the gas, but you're not going to be able to taste the actual ethanol. The other important thing that's happening here, and this is going to be even more nerdy, is in order for this fermentation to happen, the purpose of this is, during this process, there is 2 main molecules that are super important. And it's this coenzyme that is called NADH and NAD+. Okay? So at this point, we have a lot of NADH. All right? We have these molecules that are called reduced form or reduced molecules. Okay? Now, this is redox reaction, reduction oxidation reactions.
So what happened at this point, after the pyruvate that you get from the glucose to the pyruvate, we got NADH. What happened here is the fact that we're transforming pyruvate to acetaldehyde to ethanol, we get these molecules, the reduced molecule, and oxidized. We oxidize these molecules and produce NAD plus. Okay, this is the oxidized molecules. By doing so, now, well, the most important thing is, sure, we got ethanol, sure, we have gas, but now we have this ingredient, NAD plus. Why is it important? Because we need this molecule in order to go way back to the glucose and start using that in glycolysis. Okay, so in other words, we produce here 2 ATPs. From the modification of that molecule of glucose, we produce at the end 4 ATPs or 2 net ATPs. But in this case, that it happened because of we turned this NAD plus into NADH. That is why we have at this point NADH. So in other words, what we're doing is feeding that reaction, that glycolysis reaction with the oxidized form of this coenzyme NAD plus. Okay, so in other words, the most important thing is to produce ethanol? No, actually, as a matter of fact, if you produce ethanol, this is toxic for the actual organism. If this organism continue doing this, it's gonna die because ethanol levels would rise up. And then of course, ethanol, yeah, you use that to sterilize things, okay? Gas, produce a lot of gas. This can get the pH down, sure, but again, it's not really that important at this point. But ethanol will kill you, or in this case, the yeast. So this is not the main or most important thing. The most important thing is producing that piece of energy, the ATP. But the main or the protagonist of this is this NAD plus, because the fact that this molecules is reduced, we oxidize these molecules at this point is to feed that reaction that is happening, which is glycolysis. It uses NAD plus in order to continue that reaction, and by using the glucose, we produce 2 ATPs. There's some similar reactions that happen in other type of fermentation to produce other type of organic acid or other end products, but the main ingredients are here, molecules that are being transformed into something, but it is the main goal would be turning that NADH into that NAD in order to feed that glycolysis. So in other words, this is not the main ingredient for the glycolysis to happen, but it's a very important coenzyme that we need in order to get into this, which is the pyruvate. There you go. You have the nerdy explanation of fermentation and what's going on inside that bread. Let's do it. This is a 45 to 1 hour and 20 minute recipe, which include 1 cup of flour, 1 tablespoon of yeast, 300 ml of water, sugar, 1 tablespoon of salt, and 1/4 cup of oil. And I like to use the white lily bread flour. This is the unbleached version of it. So you get a balance, and then you weight the flour. And here we use 600 grams of the flour. And after you combine all the ingredients, it's just mixing time.
Let me explain you something about the dry yeast and the wet yeast. You can use both, or you can use either or. You can use 1 tablespoon of dry yeast and then you just add it to the flour, to the mix. Or you can activate the yeast, the 1 tablespoon of yeast with water and sugar, and then dump it here. What I normally do for this recipe is use half of dry and half of wet yeast or activated yeast. Now the fun part begins. So after you have the flour all mixed, you put a little bit of dry flour on the table and then the kneading process starts. You have to do this for at least 10 to 12 minutes. I did a small experiment of kneading this mass for 3 minutes, 5 minutes, 7 minutes, 10, 12, and 15. And I've noticed that perfect consistency is 12 or more. More than 12 minutes, we got the same consistency. So this is very important. Now before we continue, let me explain you how to prep the wet yeast or the activated yeast. So you have this amount of sugar in a container, you put a little bit of water, you also add the amount of yeast that you're using. In this case I use half a tablespoon, and then you mix this. You really want this yeast to get all wet and incorporated in the actual water or the actual mixture. After you have it completely wet like that, you keep adding water, again in a small container. Remember, count this water for those 300 ml, because if not, if you don't count this, you could end up with a wet dough. And after 5 minutes, this is how the yeast would look like. Let's go back to the kneading pad. You need to get this consistency. After you get this consistency, you are done. Now we're ready to roll the bread. So you cut a piece of the amount of the loaf that you want to do. Normally, I have 2 pieces of bread from this 600 grams. So in theory, it's around 300 grams per dough that I use for each loaf of bread. At this point, you roll it like I'm doing here. And after you roll it like this, you prepare an aluminum foil or a bread tray and put it on there. Now we need to let the bread to grow. And in order to do that, we need to sort of incubate this bread. Why I said incubate? Because the yeast are ready to start the fermentation and they need a period of time to grow. And when they start growing, then they're gonna start using those sugar, producing CO2 and ethanol. What I do is I preheat the oven from 130 to 140 degrees and then shut it down. When I check the oven normally is from 37 to 45 degrees. Celsius. Why this temperature? Because the yeast would grow perfectly and start the fermentation around 37 to 45 degrees. After this, I wait 45 minutes to 1 hour, sometimes 1 hour and 10, and then I can see the bread growing. Take a look at this. This is 45 minutes of growth. Then you bake this bread for 15 to 20 minutes at 350 degrees Fahrenheit.